So prime factorization. Every composite number can be written as the blank of blank blank. So Devontae gave us an example of a composite number. He gave us the example of 27, I believe. 27 is a composite number, right? So if I take this composite number, I want you to write it as, what did we do in our opener? Prime factorization. So every composite number can be written as the product of prime numbers. One method of finding the prime factor in a composite number is by using a, what did we do in our last step on our opener today?
Factor tree.
Yeah, a factor tree, by using a factor tree. So we're going to look at two examples. So on your paper it says examples, and in each example below we're going to write the number as a product of prime numbers. So example number 1, we have 35. Example number 2, we have 210. So let's focus on example number 1 first. So 35, I want you guys to write this out, 35 into prime factors. So we're going to make a factor tree. So the first thing you do when you're making a factor tree, you have to find what two factors can you multiply together to get 35. So what? 5 and 7. So when you go to do 5 and 7, you have to go down to each number here. So each factor, you look at 5. Does 5 have any other factors? No. Well, it does, but it's just 1 and 5. So 5 is a what type of number? Prime. Since 5 is a prime number, we're going to circle it. Then we look at 7. Is 7 going to be a prime or a composite?
Prime.
A prime. So since it's a prime number, we're going to circle that as well. So the prime factorization for the number 35 is just going to be 5 times 7. So when you go to write your answers on your worksheet today, you're going to come up to the right of your number, of your 35. You're going to put your equal sign, and then you're going to list your prime numbers. Well, your prime number is going to be 5 times, what's our other prime number? 7. So your final answer is going to be 5 times 7.
Oh, so that's what we do.
That's what we're doing. Yeah.
The prime numbers are the ones we
And we're going to build upon that. So every lesson that we start in here, we're going to build upon. Drew, you don't have anything that I have down.
Yeah, I know.
You're not going to stay in the seat if I can't have you working. I'm sorry, kiddo, but you got to stay with me.
Yep.
All right, let's look at example number 2. So example number 2, we have 210. Now this is a pretty large number. So there's going to be many different factors of 210. My easy trick, when I'm dealing with a large number and it ends in 0, what should I use as one of the factors? If I have a large number and it ends in a 0, what should be one of my factors, you think? 2 could be one, but that I'm going to have to work with a lot of numbers. 10. So take that 1, put a 0 behind it for 1, 0, and 10. Well, if I take that 0 off, what number am I left with? So if I take that 0 off of here, what number am I left with? 21. So my two factors here are going to be 10 and 21. Devontae, you could definitely use 2 as a factor of 210. It'd be, if you take 210 divided by 2, what do you end up with? So you'd have to use 2 and 105 as your two factors, which is completely acceptable. Remember, you can use different factors than what I use. You just have to end up with the same prime numbers. Okay, so we come to the left here, 10. Can you factor 10? What kind of number is 10 going to be? A prime or a composite? Trevon, what type of number is 10 going to be? That's a composite. So factor it for me. 2 and 5. Okay. What type of number is 2 going to be? Trevon, what kind of number is 2 going to be?
1 and 2. 1.
So can you factor 2 any further? No, so it's going to be a prime, so I'm going to circle it because I'm trying to find my prime factors here. Okay, what about 5? No, so it's another prime number, so I'm going to circle it. So then you come up to your other factor here, 21. Drew, can you factor 21? What two numbers can you multiply together to get 21?
7 and 2.
How about 7 and
73.
7 and 3? Again, you could write 7 first. I always like to write my smaller numbers first. So 3 and 7. Drew, what kind of number is 3 here? Prime. So you're going to circle it because you're looking for your prime factors. What type of number is 7 going to be? Prime. So you're going to circle it again. So now, basically, I kind of think of these like dead ends. You can't go any further after you circle it. They're all your prime numbers. So you're going to come and you're going to use these prime numbers and list them up to the right of the 210. So what are my prime numbers of 210? So 2 times. So what else? 2 times, and we're going to do them in order here because you always want to put them in order of least to greatest. Well, what comes after 2?
3.
3, then what?
5.
Times 5, then what?
7.
So there are your prime numbers written in standard form. So make sure when you come up to your 210, to the right of it, you put equals. And then you put your prime factors in standard form. I am telling you now, if you don't know this about me by now, you guys are really going to struggle. I am very particular about how I want my answers written, right? So if I'm going to grade your worksheet or your opener or your quiz or your test and I don't see it written out like this, you will lose points. I don't want it randomly written all over the page. I want your answer directly to the right of the number you're factoring. Okay? Okay, let's take a look at our second part of our notes. Our second part of our notes today are going to be exponential form. So we're going to take these prime factors that are written out in standard form, and we're going to also write them in exponential form. Oh, pause there. Exponential form. So when writing factors of a number are repeated, and we're going to go ahead and just give this to you, the prime factorization. So when factors of a number are repeated, the prime factorization can be written in exponential form to save time and make it easier to read. These are not your 2 examples, so don't write these down as your example. So, prime factorization of 288, let's pretend that I did a factor tree here. So I did a factor tree of 288 and I ended up with prime factors. I then wrote my prime factors in order from least to greatest. This is called standard form. So what we just did above when we did the factor tree and then we wrote it out in order from least to greatest, that's called standard form. When you take that standard form and you make it shorter to read, it's going to be called exponential form. So what I did there, I used exponents to show 2 times itself how many times? 1, 2, 3, 4, 5. So it's going to be, instead of saying 2 times 2 times 2 times 2 times 2, I'm just going to say 2 to the 5th. It means the same thing. And then instead of saying 3 times 3, I can just say times 3 to the 2nd. So you're going to take that standard form and then you're going to write it in exponential form. So let's look at those examples. So here are the examples that you guys want to write down on your piece of paper. The first one, you're going to write down, but I want you to stop before you write this down. What's wrong with how that's written?
It's not order.
It's not in order. So in order to write these down in standard form, you need to put them in order from least to greatest. So you can't just write 3 times 7 times 2. We're going to put them in order from least to greatest. So how many 2's do I have there?
3.
So I'm going to write 2 times 2 times 2. Okay? How many 3's do I have?
2.
So then I'm going to continue times 3 times 3,
1 7.
and then 1 7. So that's standard form. Now we're going to take standard form and write it in exponential form. So the first thing that you need to do is look. How many 2's do I have?
3.
So I'm going to put 2 to the third power times
3 to the second power.
3 to the second power times what? 7. Now, when you go to write your answers on your worksheet, on a quiz, or on a test, I want to see your standard form, then I want to see an equal before your exponential form. And then you're going to box that all together because that's all part of your answer. All right, example number 2. So we have 5 times 11 times 5 times 2 times 5 times 2 times 5 times 2. In standard form, how would I write this? How many 2's do I have to write?
3.
1, 2, 3. Okay, so I'm going to have 2 times 2 times 2. How many? Let me cross it. I like to cross them off as I go. Okay, how many 5's am I going to have?
4.
1, 2, 3, 4. So times 1, 2, 3, 4 times 1, 11? Times 11. Okay, I write too big, so I'm going to have to drop down to my equal sign. So that's the standard form. Exponential form, how would I write it?
2 to the third power times 5 to the fourth power times 11.
Times 11. Good.
Could it be 11 to the first power?
You could put, that's a really good question. So Ashley asked, would it be 11 to the first power? You could write that little 1 there, but you don't have to. Okay? Yeah, either way would be right. You wouldn't lose a point for not having that 1 there. Now, when you look at example number 3.
2, 7, 15.
Okay, but there's a problem with this. You can only write prime factors in standard form and exponential form. I don't have all prime factors in example number 3.
Leave it like that.
What number is not a prime number?
15.
15. What are your factors of 15 going to be?
5 and 30.
Yeah. So now that we have the factors of 15, how would it be written in standard form?
2, 3, 5, 7.
And make sure when you say each of those, you put a times in front of it. So 2 times 3 times 5 times 7. Now, when we go to write this in exponential form, how would I do that?
Like that.
Yeah, I'd leave it just like that. I could put a little 1 for each of the exponents, but it's all unnecessary.
That's unnecessary.
So we're going to stop there.
We done.